Tak 20
5 minutes later.
Hey, that fish actually looks fresh though.
Fresh? Fresh doesn't really mean safe.
Huh? What do you mean?
Who knows? Maybe the fish contain lead or mercury stuff.
Well, you can't even see with our naked eye.
Exactly. How do scientists know if it's safe to eat?
As we saw in a previous situation, we cannot tell whether foods contain heavy metal just by looking at it. Therefore, the sample must be prepared before it can be analyzed. So, one common sample preparation is a dry etching. Dry etching is a method where the sample is heated at a high temperature, usually between 400 and 700 degrees Celsius, in a muffled furnace. The heat burns away the organic matters and leave behind inorganic ash for the analysis. Dry etching is important in analytical chemistry because it is suitable for food and plant samples that contain a lot of organic matter. It removes organic matter completely, produce ash that is easier to analyze, and use very few reagents, which help reduce the risk of contamination. Another widely used sample preparation technique is a wet digestion. Wet digestion is a method that uses strong oxidizing acid, such as nitric acid and sulfuric acid, to break down an organic matter and converts the sample into a clear solution for the analysis. This process releases the analyzed into solution, allowing them to be accurately measured by analytical instrument. Wet digestion is especially important in analytical chemistry because it is suitable for trace metal analysis where a high accuracy is required. It produces a clear solution that is ideal for instrumental analysis such as atomic absorption spectroscopy or AAS. Now let's look at the advantages and disadvantages of both methods. For the dry etching, the main advantage is that it uses a few or no chemical reagents, so the risk of contamination is low. However, it takes a long time, usually about 2 to 4 hours to complete. For wet digestion, the main advantage is that it reduces the loss of analytes and giving more accuracy result. However, the chemical used may introduce impurities if they are not handled properly. So, both methods have their own strength and limitations, so the choice depends on the type of sample and the analysis required.
For the methodology phase of our heavy metal analysis, we look at two distinct sample preparation pathways, dry etching and wet digestion. As outlined on the slide, dry etching relies on a high temperature thermal breakdown consisting of weighing, pre-charring, furnace ignition, and final acid dissolution. On the other hand, wet digestion utilizes a liquid-based chemical breakdown involving weighing, acid addition, heating, and volume dilution. Let's take a closer look at how each of these individual procedures is executed in the lab. Starting with the dry etching protocol, our first step is to weigh the sample to record the initial mass, which is essential for calculating our final heavy metal concentrations. Next, we pre-char the sample on a hot plate. This step is crucial because it slowly drives off any moisture to prevent splattering or the sample catching fire during the high heat phase. Once pre-charred, the sample goes into the muffled furnace, where it is ignited at intense temperatures between 500 and 600 Celsius to completely incinerate the organic matter into pure ash. And finally, we dissolve that remaining white ash in dilute acid, which liquefies the left behind metallic elements so they can be properly injected into our analytical instruments. Now, looking at the alternative process, wet digestion. We also begin by weighing the sample, which establishes the exact initial mass required for accurate quantification later on. Next, we add an acid mix, utilizing strong oxidizing acids like nitric acid to actively attack and break down the complex organic bonds holding the food matrix together. We then apply heat to the mixture, which speeds up the chemical reaction and converts the organic food matrix into gas and fumes. To finish the process, we take the fully dissolved, completely transparent liquid and dilute the clear solution to a specific volume, ensuring it is perfectly prepared for precise analytical measurement.
Next, I will talk about why it been used for studying a metal in the food sample itself. First, we must know that to analyze the metal in the food, we must completely destroy the food or to study the organic matter and leaving only the mineral element behind. This process is called a sample preparation or sample digestion. For a dry etching and wet digestion, it's one of the method itself. Next, about a dry etching. Dry etching is the high and heat burn method. It dry the sample by using extremely heat to completely annihilated the organic portion of the food sample. For the wet digestion, we use a acid dissolution instead of using a high heat to burn the sample. Wet digestion use a strong concentrate acid and oxidized agent to chemical break down the food at a lower temperature to make so that the experiment become easier to study the mineral in food sample itself.
Let's look at a concrete example. The determination of heavy metals in canned fish. In this case, tuna. When we compare the criteria, wet digestion wins across almost every critical marker for fish. In terms of fats and proteins, dry ashing handles the fish oils poorly because they splatter and catch fire. Wet digestion, however, handles them excellently, rapidly dissolving complex tissues. Next, the mercury deal breaker. Mercury is the main target in tuna. Dry ashing falls completely with 0% recovery because the extreme heat vaporizes and loses all mercury. Wet digestion passes with 100% recovery because closed vessels trap volatile vapors. Next, lead and arsenic. Dry ashing is risky as elements can escape or stick to the crucible walls, while wet digestion totally retains them. Last, time efficiency. Dry ashing takes a slow 8 to 12 hours, whereas wet digestion finishes in just 30 to 45 minutes.
In conclusion, both dry etching and wet digestions are important but different methods for preparing sample for heavy metal analysis in food. Dry etching is a straightforward, safe method that requires a few chemicals and works well for processing large batches. It is effective for analyzing stable microminerals. However, it struggles with volatile contaminants because the high temperature can cause evaporation. On the other hand, wet digestions, especially when enhanced by closed vessel microwave system, is the current standard for ensuring food safety. This method uses strong acid mixtures in sealed pressurized condition. It quickly breaks down complex organic materials and allows for the complete recovery of volatile toxic heavy metals like mercury, arsenic, lead, and cadmium. Ultimately, choosing between these two techniques depends on weighing the thermal stability of the heavy metals against the chemical complexity of the food sample being analyzed.